Assalamualaikum. I want to review your exercise under collaboration space. Ada exercise that every one of you in the breakout room did last week. So we will look at it one by one. So we will start with group 5I. Group 5I. 5I, room number 1. Room number 1. Okay, let's look at this. Alright, the question is to calculate unknown displacement, or in this case is unknown rotation, because this is beam at roller support. There is a rotation. So let's check one by one. Okay, so D1, D2, D3, this is correct. And for Q, we must put position 1, 2, 3, we must put value. D1 means the moment at B, so it is the same with the sign convention, so it is positive. So this one is correct. So there is no moment at C and D, so the value is 0. So this one is correct. Okay, so now this is the equivalent element nodal forces. Okay, for element number 1, UDL is 20 kilonewton per meter. Length is 4 meter. So if we check 20 times 4, 20 times 4 divide by 2, so we get 40. Okay, we get 40. So this one correct. And then moment WS squared over 12. W is 20. L is 4 over 12. It is 26.667. Okay, so we need to compare with the degree of freedom. At near node is 4,5, at far node is 6,1, 4,5, 6,1. So at position number 4 equivalent to 40, position number 5 equivalent to 26.67. This one. Okay, position number 6 equivalent to 40. Position number 1 is equivalent to negative 26.67. Okay, correct. Okay, for element number 2, Q node 2, for element number 2, since node 2 doesn't has any load on the member, so all value is equivalent to 0. Okay, for element number 3, again it is UDL, the W is 25, the length is 5 meter. So it is WL over 2. WL over 2 is 62.5 kilonewton. Moment is WL squared. WL is 5. WL squared over 12 is 52.08. 52.08. Okay, so this one is correct. Then we need to compare at near. So this is near. At near nodes 7,2, near node 7,2, and far node is 8,3, 7,2, 8,3. So find the value in the right diagram and put into the equivalent element nodal force for element number 3. Okay, for position number 7, it is 62.5. Position number 2 is positive 52.08. Position number 8 is 62.5. Position number 3 is negative because it is opposite. So this one is opposite with the sign convention, opposite with this. So we must put negative. Okay, So total stiffness. Okay, this Q is called as equivalent nodal forces. Okay, Q naught, and this is Q naught 1 plus Q naught 2 plus Q naught 3. Okay, so in Q naught must has the same uh total degree of freedom, since in this beam there are 8, so total must be 8 position from position number 1 to position number 8. So for position number 1, we have to find the value in the equivalent element nodal force. Number 1, negative 26.67. Okay, and all this is correct. Okay, so let's move to this calculate. This is all K1, K2 and K3. Remember this symbol, this label near, far. Okay, YZ, and this label is actually is the same with label for equivalent element nodal forces. Okay, so this is okay. We calculate this using formula. Be careful with when you calculate this value. So put the right value, put the right sign, because we will use this in order to establish the stiffness equation. Okay, so this is called as total stiffness element. Okay, this is actually, the name of this is actually structure stiffness matrix. This is the right name. Structure stiffness matrix K. Structure stiffness matrix K. But as I mentioned previously, if the question doesn't ask you to give to give the stiffness, the structure stiffness matrix or stiffness matrix for the beam, this step is unnecessary. You don't need to give in full. Okay, you don't need to give in full. However, if you want to write this K, doesn't matter, it is not wrong. Okay, so all must be 8 position from position 1 until position 8. So anyway, we will focus on only to this value, because these are the value in the unconstrained system, and this value will be used in analyzing or in determining the unknown displacement later on. Okay, so how to determine this? We will get from this one. So for 1 we have to find the value 1 here plus 1 here, and then 1 2 1 3 and so on. We do it one by one until we get all this value. Okay, so once we have determined this, we need to calculate unknown displacement. D1, D2 and D3. We will use the stiffness equation. Q is equal to KD plus Q naught. Q is equal to KD plus Q naught. We use capital because this is for the structure. When we use Q naught small letter, it is for element. And when for the stiffness equation, we actually determining the stiffness equation for the whole, for the structure. So we use capital letter. Okay? Doesn't matter. So this one 300, right? This one is correct. Okay, don't forget to put EI times with D1, D2 and D3. D1, D2 and D3. D1, D2 as well as D3. You may write as in full capital. Okay, D1, D2 and D3 plus Q naught we get from this. You get from this 1 2 3 1 2 3 negative 26.67, 52.08 and negative 52.08. Negative 52.08. So we put into this here. And then what we need to do is we need to solve this equation. Okay, straight away using calculator, use 3 simultaneous equation. You don't need to do this step. Okay, this is unnecessary. This is unnecessary. If you put this, it doesn't matter. It is not wrong, but this is unnecessary. Okay, what you need to do is you have to write in matrix and straight away put into the calculator and you will get the answer. So the answer must be in unit radian because it is in the Z position. In the Z position. Unnecessary ni means that okay, I want you to straight away write in matrix. You don't need to rewrite it into 3 simultaneous equation. Okay, doesn't matter if you want to write it here as well. Okay, so next is once we have determined the displacement in unconstrained system, so we need to calculate reaction. Again, we still have to use this equation. Q is equal to KD plus Q naught. Q is equal to KD plus Q naught. Remember, this is for the structure. Please use capital letter. So this is Q, 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 Q. So we only use small letter for the member forces. Q kecil, Q small letter is for the member forces in thrust. Okay, for the member forces in thrust. So this one is capital Q. This one is capital Q because this is for the whole. Okay, so we have to solve using matrix multiplication. We need to consider the unknown displacement that we have determined, substitute into the D position, and then we can solve for the unknown reaction. So this is when unknown reaction unknown reaction determine. Okay, this is unknown reaction without considering any effect. So if we need to consider the effect of for example support settlement, of course we will get the different answer. Okay, using this we can actually straight away draw the diagram. Actually calculating internal forces using this one. Okay, as long as you can draw, as well as you can draw the diagram. So this is how we calculate using the matrix steps. Okay, however, what normally I do is I will straight away draw the diagram. Okay, let's check it together. Okay, look like this is the correct one. Okay, looks like this is the correct one. Okay, actually we can draw this straight away without having these steps. Okay, anyway, very good. Very good if you show all this how to establish, how to get the internal forces and then draw the diagram. Okay, so this is for room number 1, group group 5I. Okay, we now move to room number 2. Where is the solution? Okay, let's discuss it together. Okay, to calculate unknown, again the question is same. We need to calculate the unknown displacement. So we must label it correctly. Constrained and unconstrained. Okay, the label is correct. And then the displacement is all 0 here. So there is no moment at the moment. External moment. Okay, there's no external moment. It is only triangular load as well as the point load. Okay, so this is correct. Okay, so as usual, step number 1, calculating or establishing Equivalent element nodal forces for each element is compulsory, but make sure you have to put the right label. The right label for 5, 6, 1. This is correct. Okay, the right label for 2 is 6172. This one is correct. The right label for K3, K3 7283. This one is correct. So make sure all the value inside the matrix is the correct one. Okay, so this is to calculate the this one is the steps to calculate the equivalent element nodal forces. Equivalent element nodal forces. Okay, so we need to calculate the vertical reaction as well as moment. Vertical reaction as well as moment. So okay. So by looking at the step, this look like correct answer. Alright. Okay, so Q not 1 label. This label same with the label for K. So 1 must be negative value. Negative value is 55.1. So this is correct. This is correct. No member, force on member at element number 2. So this one is correct. So we plus all this. So this is called as equivalent nodal forces, and symbol. The symbol is Q capital. Q capital. Okay, so this step is correct. So this is all. This is the stiffness equation for the truss. For the beam. In full. So as I mentioned, this is unnecessary unless the question asks you to do so. So if the question asks you to give the stiffness equation, so you need to give in full. In full means in this. Okay, you must fill in like this. Fill in this with value, because matrix is symmetry. Okay, so we will solve this. Okay, this one is in terms of EI, so make sure you put the correct value. And then this is how to continue. Okay, we are going to continue with calculating unknown reaction at the support. And don't forget to put the unit. Okay, don't forget to put the right unit. Remember that in this beam, there is one moment here. So at position moment, you need to put the right unit. Okay. So this is how we calculate the internal forces in the beam. Okay, internal forces in the beam. We use the formula. Of course, it has 4 position for one element. So label is equivalent to what we have labeled in K. In K, so we have all this value. We have all this value, but actually we can draw it straight away without showing all this. Okay. Okay, let's check the value together. I want to if this is the correct one. If this is the correct one, this is the beam. Okay, Q4, 5, 6, 7, 4, 5. Okay, where is the question? Okay, fix. Okay, fix roller. Fix roller. Fix. Fix roller. So moment 4, 5. 5 is moment. Moment means this is 60.10. 60.10. 60.10. 4 is 79. 4 is 79.48. 79.48. 6 is 57.76. 57.76. And then 31.06, and 74 or 94. 74 or 94. Yeah. Is it 7 or 9? 94. 94. 94.20. Okay. What type of load in this question? 150. 150 and 20. 26. 150 and 20. 75. 150 and 75. 150 and 75. Okay. 150 and 75. 75. Okay, we check the equilibrium. We check based on total Fy. Total Fy it is 79.48 minus 150 plus 57.76. Okay, plus 31.06 plus 94.2 minus 0.5 times 0.5 times 75 times the distance is 3 meter. 3 meter. Okay. Okay, this is correct. Okay, this is correct one. This is correct one. So, okay, we try to draw the diagram for this. Draw the shear force diagram and the bending moment diagram. Okay, now we will draw the shear force diagram. Shear force diagram for this beam. Okay, for this beam, start with 0, go up 79.48, straight minus 150. So it is 79.48 minus 150 plus 57.76. Go straight. Go straight like this. It is negative 12.76. Negative 12.76 straight plus 31.06. We get 18. Is 18.3. Minus 0.5 times 3 times 75. Get 94.2 negative. Somewhere here. This is 94.2. So negatives are going up. Okay. So it's actually like this. Start from 79.48 minus 150, we get 70. Start with 79, we get 70.52. 70.52 plus 57.76, get 12. This is 12.76 plus 31.06, we get 18.3, and then we get 94.2. So this one is positive, negative, positive, negative. Okay, so this is the shear force diagram. Shear force diagram. So the diagram that you have given to me is actually wrong. Okay, then use this. This is the shear force diagram. This is the shear force diagram. We will use this area. We calculate the area of this diagram in order to plot the bending moment diagram. Okay, bending moment diagram. So the area, remember that the bending moment diagram is the area of shear force diagram. So continue lah. BMD. So BMD. Okay. So remember that moment is the area of shear force diagram. Okay, so I think I have to stop right now. So we will continue to discuss another answer after this. Okay, in the next video. Okay, thank you. Wassalamualaikum warahmatullahi wabarakatuh.